All right, everybody. Welcome to the February edition of the CFAS General Meeting. I am Wesley Clem, the president of the Central Florida Astronomical Society, and let's get this show on the road. So it is February 11th, and if you are here and watching, I hope you're a member, and if you're not, why not? You have access to our private events and dark sky parties out in Geneva. We have a loner scope program and a remote observing program where you can borrow a telescope or get time on our Sea Star that's out at Starfront Observatories right now. So if you haven't tried out one of those and you are a member, you should. We have an online community on groups.io where you can discuss topics in astronomy, ask questions, use it as a learning opportunity, or just get to know your fellow astronomers in the area. It's a great place to be social. If you're not on there already, please get on there. I highly encourage it. We have our quarterly meetings at Seminole State's Planetarium, the Emile Bueller Planetarium out at Seminole State. It is a fantastic place for an astronomy club to have a meeting. So if you haven't been to one of those, ours is next month. I think it's on March 7th. So join us there. You also get membership to the Astronomical League. So that gets you access to the Reflector magazine and all of the bonuses of being an Astronomical League member. So check that out if you haven't already. And of course, we're also a nonprofit 501(c)(3) organization. We are all volunteers here. Any and all donations and proceeds for dues of membership all just go to the club and furthering our mission to spread science and astronomy to the community. So you also get discounts to Astronomy Magazine and Sky and Telescope Magazine. So if you're not already a subscriber to those, I do encourage it. Those are great ways to stay up on what's up in the night sky. Tonight's agenda, we have Dr. Neil Farber. He's going to do a talk on astrobiology, the search for life, followed up by club news, upcoming events, both club and astronomical. And then finally, our astrophotography showcase. We had several images in the last couple months, so stay tuned for those. They're looking good. So uh, now I guess I will hand it over to Dr. Neil Farber. He is a NASA and JPL Solar System Ambassador. Dr. Farber, who is a professor emeritus of medicine at UCSD, practiced general internal medicine for 40 years, teaching, researching, and providing patient care initially on the East Coast and more recently at UCSD, retiring in 2019. Dr. Farber has been a docent at the San Diego Air and Space Museum for the past 6 years. As a NASA JPL Solar System Ambassador, he has given lectures and classroom exercises about different topics of space exploration at various schools, libraries, astronomy clubs, retirement homes, and community centers. Welcome, Dr. Farber. Thank you so much for being here. So, if you're able to go ahead and share your screen, go ahead, and thank you so much for being here.
Thank you so much for having me. You should be able to see my screen now. Yes?
Yes,
Okay.
the whole screen.
Yep, good. And okie dokie.
Here we go.
All right. So humankind's primary questions have been many, but two of the ones that interest me the most are we alone in the universe? And that's any intelligent life, as well as, more importantly, any type of life at all in the universe. And then the other question is, how did life start on Earth? And you'll see during this lecture, and correct me if I'm wrong, but the first question I'm not going to be able to definitively answer, but I will tell you that we're getting awfully close. And the second question, I think I could pretty confidently answer how that happened. And you'll see the information that I have about that. So how do you look for intelligent life? The first thing, I just have to get rid of something. Okay, is mainly through SETI, the search for extraterrestrial intelligence. And those are radio telescopes looking for repeated signals or signals in patterns. And we haven't found anything positive as yet. So that's pretty easy to answer. However, if you look at the number, why am I not? Okay. There's no direct evidence of life elsewhere, but if you look at the number of um, galaxies there are in the universe and how many stars are in each of those galaxies with planets around probably all of them, you'll see in a minute that the overwhelming likelihood is yes, there is extraterrestrial intelligence. We just haven't seen it yet, but I'll get there in a minute. There's no direct evidence of life anywhere else, not directly. There are some biologic signatures that are being sought, including evidence of carbon dioxide and especially oxygen, and evidence of organic molecules. And you can also look for habitability, and there are three necessities about that. First of all, persistent liquid. We usually look for water because that's what we use to on Earth. There's a possibility of other liquids sustaining life, perhaps. You look for the key chemical ingredients of life, and by that we're talking about carbon, nitrogen, oxygen, hydrogen, phosphorus, sulfur are the main ones, and any of the particular molecules that are made out of those, and then an energy for metabolism, because that's a necessity also. So we look in two different areas: distant stars, and we're talking about exoplanets, as well as in our own solar system. Well, there's about 1 trillion galaxies in the universe, about 300 billion stars in the Milky Way. So somewhere around 3 times 10 to the 24th stars in the universe, which means more than all of the grains of sand on Earth in terms of the number of stars. So there's a very good possibility of life somewhere else in the universe. And so far, 6,000 exoplanets have been discovered. Now, obviously, those 6,000 are all stars that are near to us. It doesn't, not even elsewhere in the Milky Way, let alone the universe. But even close up, we're starting to see some things that are really interesting. And the way we find exoplanets is one of three ways: through radio velocity, transit, or direct imaging. So radio velocity uses a Doppler shift, and it only gives us the planet's mass and its orbital, where its orbit is in relation to the star. But it doesn't really tell us anything about atmosphere. And the way this happens is that the planet orbiting this star tugs on the star, and you can see the shift in the star's visual Doppler because of its being tugged to and fro from our observing point of view. Transits are a better way of looking, and that's measuring changes in brightness as a planet passes in front or behind its host star. At best, the dip in brightness is 1%, but it gives us not only information about how big the planet is and where its orbit is in relation to the star. You can also tell the planet's surface temperature, and you can study the planet's atmosphere through spectroscopy. And so this is basically a planet that's orbiting in front of a star. And as you'll see in a second, as it comes in front of the star, it's sort of like an eclipse. And basically it dips the brightness of the star by as much as 1%. NASA's Transiting Exoplanet Survey satellite has been able to pick up a lot of these. And for example, you see that basically this planet has a brightness of, if you take its brightness as 100%, its dip down here is about 0.03, meaning about 3% of the amount of output from that star. And it can easily be picked up by the satellites that we have now. But the real way you want to be able to image some of these exoplanets is by direct imaging, and that means taking a photograph of the exoplanet and doing direct spectroscopy. Well, the problem is that if you have a sun-like star, just like the Earth, and you have a hot exojupiter, which you wouldn't expect to have any life, which is really what we're looking for, but at least you know that there's a planet there, it's 1,000,000 times fainter than the star itself. So that would be looking at a lighthouse and trying to see a firefly next to it. You go to an Earth-like exoplanet, it's 10 billion times fainter. So that would be like one bioluminescent algae next to a lighthouse. It's impossible. But NASA is actually now able to do it. This is an actual image. And there's something called a coronagraph that's used, which electronically or physically blocks out the sun's light. And then you're able to see 1, 2, 3, 4 orbiting planets around this star. And so NASA has been able to actually image a lot of these planets through the James Webb Space Telescope. So we've discovered over 6,000 exoplanets, as I said. The first thing you want to do is detect the planet and characterize it. And so you want to know, does it have an atmosphere first? What molecules are present in the atmosphere, and could that support life? And finally, does it have life? Well, we're all the way to down here. We have no proof that any of the exoplanets have life. But again, we're getting very close. And I'll talk about that in a minute. When you're looking for habitability, most of the planets usually that we're looking at in terms of exoplanets are either too close, and therefore the surface is too hot, or too distant, and the surface has no liquid water, therefore it's all frozen. Or it's, but there are actually several hundred planets that have now been found in the habitable zone. We've found one planet that has carbon dioxide in its atmosphere, none with oxygen yet. And this is looking at the habitability zones of different stars. If the star is much hotter than the star we orbit, the sun, the habitable zone would be further out. Ours is here. And if it's a cooler star, like many of them are, the habitable zone would be closer in. One of the systems we've begun looking at is the TRAPPIST-1 system. And you see that it's a cooler star than we have. Sorry about the dogs, by the way. And Earth is smack dab in the middle of our habitable zone, obviously. But there's 1, 2, 3, 4 planets that are either on the edge of or in the habitable zone that we haven't looked at yet. And so NASA has plans on using the James Webb Space Telescope to begin looking at these in the not too distant future. And James Webb, as you know, is the telescope that was launched Now, almost 4 years ago, it is in the Lagrange area, L2, I think it is. So about 900,000 miles from Earth and able to pick up, and it's an infrared telescope. So able to see these planets pretty well. Well, one of the things that James Webb found in 2023 was the planet K2-18b. It's about 120 light years from Earth, and it's in the habitable zone of a star. And originally in 2023, they found the possible detection of dimethyl sulfide. Now, dimethyl sulfide on Earth is found only as a metabolite of living things. It's not found in any other way. It was reconfirmed as of 2025. And not only did they reconfirm the dimethyl sulfide, but they've found also dimethyl disulfide, which is another biologic metabolite. So it's being investigated to see, can dimethyl sulfide and dimethyl disulfide be formed in any other way? Because if scientists find that the only way of finding this is with a biologic mechanism, it would mean that we have detected our first planet that has life other than Earth. So we're getting close. Okay, let's switch to our own solar system. The first place to look for is Mars, and we're mainly looking for ancient life. Mars, as you know, is quite an arid planet. There is no water on the surface, usually. Occasionally there is actually outbursts of water, but most of the time it's very arid. But it's looking for ancient life there. We have maybe some evidence of habitability in other bodies that I'll talk about, but no actual life yet, but we're looking. Okay, on Mars, the early rovers had a suggestion of water. There were outflow channels, layers of rock, and Curiosity confirmed the presence of water. And the water we know was probably present for about 1 billion years, until about 3 billion years ago or so. So 1 billion to 1.5 billion years. And this is at Gale Crater. Perseverance also confirmed evidence of water around Jezero Crater. And the findings of Curiosity, if you look at it, the surface all around the landing site are made of pebbles. Excuse me. And these are all sedimentary, and many of the rocks and pebbles are rounded, which indicates erosion due to liquid water sometime in the past. And further away, there's more extensive sedimentary rock that's seen. All of this rock was low in salinity, had a neutral pH, and therefore was a habitable environment and was relatively young in the solar system history. The other findings that were found through Curiosity and Perseverance were all, through the spectrometer, were all of the building blocks of life that we talked about, as well as organic molecules. And that means two things. Yes, that can happen naturally. You'll see that later. But also could mean that it's biologic in origin, meaning ancient life. This is a picture of one of the areas around Gale Crater that Curiosity looked at. It's called Mount Sharp. And if you look at it, you can see clearly these layers of sedimentary rock, indicating the presence of liquid water in the past. And the other thing is there's sulfate-bearing units, clay-bearing units, and hematite-bearing units. And all of this indicates uh, liquid water on the surface of Mars in the past. And again, these are those rounded pebbles, and the only way this can happen is with water or uh, high pressure air. And yes, Mars does have an environment, but it's about the 10th of Earth's, and the air never gets, even at high speeds, never gets that consistency that it could actually round out pebbles. The other thing that was seen was rock with pure sulfur, again indicating liquid water. Perseverance, as I said, landed at Jezero crater now 5 years ago. And by the way, next week is its 5th anniversary. The location was a river outflow channel and delta, which is the best place to look for ancient life, because as the river comes down to an outflow channel or a delta, it slows, and all of the material it's carrying drops out, meaning all of the stuff from up high, which would have contained life if it's present. And so therefore, Perseverance has been drilling for core samples, which are stored in titanium tubes. These are some of the eroded stones at the landing site. And more interestingly, within the last year, Perseverance has found this rock at Chayava Falls, and it's called the Chayava Falls Rock. It's an arrow-shaped rock. But you see that there are these stuff on it, it's the only way of describing it, that has a white center, a dark rim. Perseverance found that these seeds, as I call it, had organic material and ferrous sulfate and ferrous phosphate. On Earth, this combination occurs only in volcanic areas, and there were no overt volcanic areas near where Perseverance was, or biologic origin. So there's a high suspicion that this actually is indications of organic life in the past. It's sort of a fossil, if you will, of organic life. And for all the world, as a biologist, to me, these look like either bacterial mats or mold. So it is likely that this will eventually, when those titanium tubes come back to Earth, indicate that there was organic life on Mars in the past. And so there is a future mission, as you probably know. Perseverance is sort of depositing all these on Mars. It will then, once the mission is in its once the mission is proceeding, the lander that is planned will land next to Perseverance. Perseverance will collect the samples, deposit them into the lander, and then the lander will launch into a orbit around Mars, which will be picked up by the other part of that lander and return to Earth these titanium tubes for study. And the plan is to determine if the organic molecules are biologic in origin. So this is the Mars Sample Return Program. It was originally going to be funded by NASA. NASA decided it was too expensive, and so cut the funding, but is looking for other partners, other countries, other private enterprise to join with NASA to actually fund this kind of program. Now, there are other bodies in the solar system that might have free water. They're not in the habitable zone. There's not enough energy from the sun, but they do have the chemicals needed for life. And so you say to yourself, how could they still have life? Well, let's take Europa as an example. It's one of Jupiter's largest moons. It has 2 times the ocean of Earth below an ice crust. The ice crust we know is about 10 miles thick. But the ocean is twice as big as that of Earth's. It's way out of the habitable zone, but since it does have a liquid ocean, it has energy. And there's actually been shown to have plumes of ocean water spraying out through the cracks in Europa into space. It also does have rock mantle below it, which is heated and therefore liquid itself. So it has plenty of the minerals needed for life. And if you look at the surface, you would expect if Europa was just an ice planet, it should be just pure white, just like Ganymede is. And yet there's schmutz on the surface. That's the only way of putting it. The material is both the magma from below as well as organic material. And this is a good indication that there is all of the substances needed for life down below in that ocean below in Europa's surface. The reason that it's so large is because there aren't any continents in the way. Yes, there is a fairly large mantle surrounding a core, but other than that, it's all liquid water until you get to the ice above it. And in fact, if you look at the comparison, Earth is not really a water planet, it's a rocky planet. All of Earth's water fits in this little circle compared to the rest of the planet. With Europa, almost half the planet is water compared to the rest of the planet. And the reason this happens is because of tidal heating. What happens is that Europa has a very eccentric orbit around Jupiter. As it orbits Jupiter, it is tugged and pulled, and that causes friction, which causes tidal heating, which causes liquid water and liquid mantle. And if you look on Earth at the bottom of the ocean, you see these hydrothermal vents. Okay. And it's the same kind of thing where you have these hydrothermal vents spewing out magma from below. It heats the water around it. And Earth and the water except at these vents is close to freezing. And yet if you look at these hydrothermal vents, you see all these critters crawling around. And so the obvious thought is, well, if you have all these clams and lobster-like things and shrimp-like things and algae and tube worms and all kinds of stuff like that there, why not on Europa? And it's definitely a possibility. So NASA has developed and launched the Europa Clipper. It launched a year ago. It is on its way to Jupiter, where it will orbit Jupiter. This is the Europa Clipper. I had the pleasure of and privilege of seeing it being put together at JPL when I went there for a visit. And it's in the high bay, which is huge. And this is actually the largest probe sent to another planet that's ever been launched. It'll take 6 years to reach Jupiter. It will orbit Jupiter, which swings around Europa. And this is to avoid the high radiation that's around Europa, which occurs because of Jupiter. So it will do 50 swings past Europa over 2.5 years. And the swings will put it right through the liquid water that's spewing out of Europa, so it can sniff and see, is there habitability below that ice. NASA says it's not meant to determine if there's actual life. If you ask the scientists, they'll say this and the same thing. NASA is not meant to determine there is actual life. They do it while they're winking at you. So I think there's a hope that maybe they will find some information that leads one to believe there's a possibility of it. It's going to look at the consistency of the ocean, both by radar as well as spectrography of the plumes of ocean water. And it's also looking for possible sites for future landers or rovers. Another moon to look at is Titan, which is Saturn's largest moon. It also is far beyond the habitable zone, but similar to Europa in some ways. Now, Titan is sort of like Earth, but not sort of like Earth. Its atmosphere is nitrogen, just like Earth's. The pressure is only about 50% larger than the pressure of Earth's atmosphere. The temperature is a little different. Earth's average temperature in the atmosphere is 77 degrees Fahrenheit. On Titan, it's minus 280 degrees Fahrenheit. Earth has a liquid water cycle. Titan, because it's so cold, has a methane liquid cycle. On Earth, both the surface rock and the crustal rock are silicon dioxide. On Titan, the surface rock are organic material as rock formations. And the crustal rock, the deeper rock, is water ice. The atmosphere on Titan is hazy due to that atmospheric organic material. And this is an artist's view of looking at Saturn in the distance. And the presumption is that Titan has all these lakes and rivers of liquid methane running through it. And you say to yourself, well, that's another liquid. Could there be life supported on the surface of Titan? The problem is how cold it is and the lack of energy on the surface. And that makes it a little less likely that liquid methane could be used as a substance to support life. But if you look at it, it has an ice shell, just like Europa. It has this deep ocean, which is about 10 times deeper than Earth in terms of how big it is. And it's liquid. And it's liquid for the same reason, that is the tidal heating. And there are also cracks in the surface that allow these organic materials to penetrate into the liquid ocean below the surface. So there's thinking that perhaps the inner ocean on Titan could potentially harbor life. In order to be able to explore that a little bit, there's a Dragonfly mission that'll be predicted to launch in July of 2028, so another couple of years. It'll arrive on Titan in 2034. It's a lander with flight capabilities, so it can hop from place to place. And it will explore both habitability as well as prebiotic chemistry. And this is the Dragonfly lander. It looks like a little toy. Actually, this thing is about the size of an SUV. Because of the density on Titan, the helicopter blades don't have to spin as fast as they do on Mars. On Mars, Ingenuity had rotors that turned at like, I forget, I think it was 50,000 times a second or 10,000 times a second, something like that, to be able to sustain it. That won't be necessary on Titan, they'll be able to be almost just regular helicopter blades. Enceladus is, again, one of the smallest of Saturn's moons. It orbits closer to Saturn than Titan does. It has geysers with ammonia-rich water. And you see it's mainly an ice shell, but this is an artist's conception. It does have these cracks that is spurting water out into space. And Cassini had, when they went over some of the data from Cassini, found some interesting things. There were large amounts of dihydrogen, which is evidence for hydrothermal vents, just like Earth's. Don't ask me why, I don't know. But that is an indication of hydrothermal vents. There was an abundance of carbon dioxide and methane, so organic material. There was new findings recently when they went over the data that there was phosphate in the plumes of water. And phosphate on Earth is part of DNA and also involved in energy transfer, allowing you to move your muscles, for example. So NASA has plans for a flagship mission in the future that'll be an Enceladus orbilander, that is an orbiter and lander, to be able to more thoroughly explore Enceladus. So there's lots of worlds in our solar system that have water. I mean, obviously Earth, but you look at it, Enceladus has water. Europa, we know, has water. Pluto, when they went to even Pluto, because of Callisto, or not Callisto, its moon, and I'm losing it right now. Not Theron. Yeah, Theron, I guess. It has, because of tidal heating there, it has a fair amount of water locked in below the surface. Triton has a lot of water, it's believed, again, because of tidal heating. Callisto does, Titan does, Ganymede does. So there's an amazing amount of water in other worlds in our solar system. And more recently, James Webb Space Telescope has seen that many of the proto-planetary disks have a lot of water in them, which then gets incorporated into the rocky planets that are, and the rocky moons that are in their own individual solar systems. There's also some new updates that answer the second question about how did life start on Earth. You may have heard about this. There was a Japanese spacecraft, Hayabusa 2, that explored the asteroid Ryugu from June of 2018 to November 2019. It returned a sample, sorry, that should be asteroid, returned a sample of the asteroid. It was about 5 grams worth, so tiny sample. But in that sample, when it was evaluated, was this guy, uracil. Now, if anybody remembers their biology, uracil is one of the nucleotide bases, and it makes up part of RNA. Now, they didn't find anything else, but it gives you a sense that maybe there's some things happening to asteroids, and these are asteroids that have been just orbiting in the solar system for 4.5 billion years. They haven't been part of anything. But it gives you the idea that these asteroids that are carbonaceous may be able to form some organic materials simply because of the energy from the ultraviolet energy from the sun over billions of years. And you say to yourself, well, wait a minute. There were experiments by Harold Urey, if you go back to the 1950s and 60s, where he took organic material, put it in a jar, ran electricity through it for several years, and all he got was mainly goo. He didn't find anything like this. But the two things are, first of all, this wasn't electricity. This was ultraviolet energy from the sun. The second thing is that was over a few years, not over either hundreds of millions or billions of years. And so totally different situations. And it bespeaks the fact that maybe some of the things were some of the ways that Earth could have developed life would have been through one of the asteroids splashing down in Earth's warm liquid waters, or if the ultraviolet from the sun actually directly caused some of the organic material on Earth to do that. Well, there's one interesting finding more recently from OSIRIS-REx. OSIRIS-REx was a probe that was to return and analyze a sample of a carbonaceous asteroid. And the way it was going to do it was this. This is the probe, and had a long arm that went down onto the asteroid, blow out gaseous nitrogen, which is inert, and then pick up all of the little pebbles that got blown upward into this disk. Put the disk into a heat-resistant container and send it back to Earth. The target was Bennu. The size was about almost 500 meters, so about a quarter of a mile in diameter. And it's a spheroidal shape, spinning like a spinning top. And you see it's basically one of the near-Earth asteroids. Okay. It's orbiting near Earth. It goes out as far as close to Mars, but it's a near-Earth asteroid. So some of the findings, and it brought this stuff back. The stuff has been looked at on Earth. The capsule opened, the stuff looked at. For those of you who might remember your biology, these are 14 of the 22 amino acids that are required for life on Earth. What it also found were these. Along with uracil, these are all of the nucleotides that make up DNA. Also on Bennu was recently found ribose, which is the backbone for RNA. So you have all of the material necessary for all of the genetic material on Earth. And in fact, one of the theories is that the early life on Earth was not DNA driven, it was RNA driven because it's easier. And that basically it's simpler, easier, etc. And that the more complex life, what happened is one of the larger cells swallowed an RNA cell, incorporated its RNA to make messenger RNA, and that's how more advanced life came about. But we now have fairly good evidence of how life came about on Earth, either through one of the asteroids splashing down or this actually happening on the Earth itself. And this is DNA, and the DNA that is all of us might have come from an asteroid that is similar to Bennu, except for the fact that it actually splashed down on Earth, whereas Bennu did not. So in summary, there's no evidence for intelligent life, but there's so many planets in the universe. I mean, it's incredible how many planets. It's extremely likely. And we're getting really close to the point where we can say, even in the exoplanets near us and or the planets, other planets and moons in our solar system, that we know there's life. And we're close to saying it, probably within the next 20 to 30 years. There's no definite evidence of life elsewhere, but like I said, there are many planets and moons with habitable conditions, and we're likely to find life within the next 20 years. And I will answer questions.
Awesome. Thank you so much, Neil. Very nice. Um, I did have one question come in. Let's see. John Pinto asks, isn't there a problem with very deep oceans being detrimental to life forming? Specifically, the high water pressure at the bottom of these very deep oceans creates a layer of ice covering the crust, which prevents any circulation of minerals needed for life.
No, and in fact, if you look at, I mean, the ice you think would prevent circulation of material, but the mantle is where a lot of the material comes from. The carbonaceous material, uh, if there's cracks in the crust of the ice, that could also allow for carbonaceous material to get down there. And it's not, the pressure is not a problem. If you look at Earth's oceans, which are, 12,000 feet deep or more, 14,000 feet deep, where those hydrothermal vents are, the pressure is at about, I don't, probably many, many times the pressure on Mars, on Venus's surface. And yet there's plenty of life around those hydrothermal vents on Earth. So the pressure is not a problem. The only problem would be in terms of the ice preventing circulation of material. But there's, at least in Europa's case, there's cracks in the crust that allows material to get down from above, as well as the hydrothermal vents providing other material from below.
And so even if it's just the occasional crack here and there, that's probably enough to at least answer the possibility that, like, well, if the crack is there, then there might be something churning
Sure,
through.
and we see see those spurts of water all the time. I mean, it's not occasional. It's fairly common.
There's another question. How
Mhm.
about supernovas, especially in star-dense areas? They can kill regularly all life on planets nearby.
Yes, and that is true. Luckily, there's none near us. um, yes, supernovas do kill. I mean, there's lots of reasons why planets may not have life or may have had life and no longer have life. Supernovas, a planet gets bumped and is now no longer in the solar system. They're a wandering planet, those kinds of things. Um, there are also planets that will never form life because they're too close to the star, or too far away from the star and don't have the tidal heating. Um, so, there are lots of. I'm not saying that there's life on every single planet in the universe. Um, that's an impossibility. But there's so many planets in the universe that the possibility of life elsewhere is fairly great. Um, Drake sort of didn't. I mean, anybody could take the Drake's equation, and there are lots of suppositions involved in that. Um, for example, when Drake first formulated it, he didn't think that there were many exoplanets. Well, we now know that almost every star has at least one exoplanet, if not many. Um, he thought that there were, maybe several billion galaxies in the universe. We now know there's probably about 1 trillion galaxies in the universe. So, we've gotten more and more information that leads us more and more to the idea that yes, there is life elsewhere. We just have to try and find it.
Um, John Pinto did follow up saying, we have very shallow oceans compared to the other planets and moons we've been talking about. And by crust, he meant the mantle at the bottom of these oceans. So
Uh,
I think he's hinting that the water that's on Europa is a heck of a lot deeper than what we've got, and so the pressures are wildly higher.
I don't know wildly higher. They are higher, certainly.
Yeah.
And but we know that there is material on Europa's surface that indicates that there is liquid, liquid mantle, i.e., magma, that is spurted into the water. Because otherwise, the surface of Europa wouldn't have that material on its surface. It would be just pure ice. Um, so it's still open to question. He may be right. The pressure may be high enough that life can't exist there, couldn't have formed there. Um, if if it turns, the one thing I will say is that we know that on Earth, the life that is that at those hydrothermal vents, about a third of it has no relation to any other life on Earth. And that doesn't mean they're aliens. What it means is that at least some of the life at those hydrothermal vents formed down at those hydrothermal vents. Um, and that those hydrothermal vents are are higher than the atmospheric pressure of Venus's surface. Venus's surface is about 3,000 feet of ocean water. Um, the Earth's hydrothermal vents are at 14,000 feet.
Yeah.
So many times the atmospheric pressure of Venus at the surface, which squashes everything flat. So we know that life presumably could start at those pressures. Um,
The life finds a way.
could it start at Europa's pressures? I mean, it's a possibility. We don't know for sure. That's why we want to go there and try and find out.
We gotta go look. Yeah.
Yeah, we got to look.
Next one. Ray Gregory. You made a Dr. Farber, you made a reference to the MSR mission, the multi-mission program is being reevaluated from a fiscal perspective by Congress. Does this present a setback and precedent relative to future multi-mission retrieval programs?
Oh boy, I'm not supposed to enter into this discussion. uh, they warned us not to get political. Um,
Yeah.
so,
That was recently.
so,
Was that today or the last couple of days? Yeah.
uh, so yes, sort of, I guess. I mean, I don't, it's unknown because, I mean, you can only go with what you have at the moment. Uh, and things change. All I know is that basically for the Mars retrieval program, the Mars return program, um, it was originally funded by NASA. It NASA then changed its mind and decided not to fund it. I guess Congress officially defunded it, but that does not mean that it can't be done through partnership with other nations and private enterprise. Hopefully, it will be. Um,
Yeah.
if not, we're not going to get those tubes until we have boots on Mars.
Right. That's the thing, right? Is like maybe this is a short-term setback, but that little titanium tube and rock isn't going anywhere. It's just going to sit
It's
there
not
until
going. It's not going
so.
anywhere. And some point in time, we will find a way. I'm convinced to pick those tubes up and bring them back to Earth.
Yeah.
It may be with a lander, and maybe with an astronaut physically picking them up and stowing them in his pocket. But
Nice.
somehow I
Yeah.
think we'll get them back.
I hope so too. Debbie asks, what happened to all the water on Mars?
Good question. A lot of it is trapped below the surface. We know there is an aquifer below the surface and below the ice caps on Mars. Uh, so, at least some of it is still on Mars. Some of it is not. A lot of it is not on Mars. And what happened is, for some reason, and we don't know exactly why, Mars probably originally did have a magnetic field. Um, it somehow lost its magnetic field. When it lost its magnetic field, it lost its atmosphere. When it lost its atmosphere, it lost any of the water that was on the surface. The rest of it became ice or is trapped in aquifers below the surface. And they do actually occasionally spurt out onto the surface of Mars, even to this day. We've seen changes from one rover to the next, or one orbiter to the next, in terms of like looking and saying, and and it not being what you think of as just wind produced changes. So it's likely that there was expulsion of water from below. And
Mhm.
the other thing is the orbiters using radar technology did actually see um, fair amounts of water trapped below. And
So
that may be a source of current life on Mars. If there was life, a billion, 3.5 billion years ago on Mars, and some of it got into the water below the surface, that could sustain continued life on Mars. So we don't know.
certainly, yeah. I mean, those cores that we're pulling up out of Antarctica,
Right.
3 million years since the last time they seen atmosphere. Yeah,
Yeah.
just like that. Perfect. That wrapped up all the questions. So, yeah,
Okay.
thank you so much, Neil. I really appreciate it.
My pleasure. Glad to be here with you guys and have other talks if you want.
Awesome. Sounds good. I'm sure I'll be in contact.
Okay.
Thank you so much, Dr. Farber.
Take care.
All right. Back to it. Okay. Continued on. Thank you so much to Dr. Farber for that really interesting talk on life. I mean, we all think it's out there, right? I hope we find it in our lifetime. That's what I'm crossing my fingers. So, okay. There we go. Next up is club news. Okay, so this weekend, February 13th to the 14th, we tentatively have our Dark Sky Nights out in Geneva. We are actively looking at the weather right now, I think, tentatively. Watch for that announcement on groups.io, but tentatively Friday is a go. And Saturday might not be, but we are watching the weather. I think Denise is going to make the announcement either later tonight or early tomorrow, so keep an eye out for that. Um, we still, as always now, we have our remote Sea Star out at Starfront. If you are not using that and want to, be sure to join the groups.io subgroup for that, the Remote Observers Program. You'll talk to Pete, he'll get you all set up, and then you'll be able to use a telescope out in Bortle 1 dark skies. I think it's been fairly cloudy this winter out there, but it's going to be clearing up soon. So get on that if you haven't. We have some really cool images coming out of that. Speaking of groups.io, if you are not on there, whether you are a member or not, if you're not, you should be. Try to get on there. That's where we have all of our announcements, our calendar, community help. Be sure to join in on the fun there so that you can know what's going on with the club. Um, Also, big welcome to Paul Morrow. He is the new chair of our Loner Scope program. He joined up last month to help us out with that program. He's going to be the one that's might meet up with you along with those on his committee to loan out telescopes, tinker with the ones that we have, and generally like take care of the gear that the club has. So a big welcome to and thank you to Paul for helping us out with that. And also, of course, a big thank you to Christopher Hunt for everything that he did as the Loaner Scope program chair. I'm sure if you ever borrowed a scope from the club, you interacted with Chris, and he just did a fantastic job over the last several years taking care of all of our gear, and making sure everybody got a chance to borrow a scope if you've had one. So again, Chris, big thank you. For the record, he's not going anywhere. He's still in the club. You'll still see him out at Geneva. He just had a change in schedule with work, so he didn't have the time for the loaner scope chair anymore. But he's still going to be around. He's just taking a step back. So again, thanks, Chris, for everything that you did there. On March 7th, right before our in-person general meeting, John Sasson is going to be having a Telescope 101 course. So if you're relatively new to astronomy, and that's why you joined the club, I do recommend getting in on this. It'll be at 4 p.m. right before the meeting out at the planetarium. If you're new to the telescopes or maybe intermediate or you just want to join in on the fun, feel free to come visit in on that, sit in on that, and see. I mean, I'm hoping to be there too. I'm sure we'll all learn something. So, thank you, John, for putting that together, and I look forward to it.
Hey,
And
quick
like I
quick
said,
correction on that, Wes. It'll be
yeah.
mostly Derek and Eric from the planetarium going over old telescopes. I'll be there to help, but
Oh,
they're the ones really hosting it and have way more experience with visual than I do. So
perfect. Okay. Well then, thank you, John. And so thank you to Derek and Eric for running the Telescope 101 course. I appreciate the correction. Thank you. And then immediately right after that, we have our in-person meeting on March 7th. So that'll be from, I think it's 6 p.m. until like 8 or 9, something like that. So be sure to join in on that. It's going to be at the planetarium right after that course. So be sure to join us in person. We'll probably have a little planetarium um, show or demonstration of some sort. And then we're still working on the exact layout of the meeting, but stay tuned for what that's going to be. Let's see. Outreach opportunities. If you have not participated in outreach, I highly recommend it. It's very rewarding. Having a little girl or boy look through the telescope and seeing Saturn for the first time and like, either going, whoa, or questioning if it's real. It's just so very satisfying. And I mean, it doesn't even have to be a child, I've been with like an elderly woman looking through and seeing Saturn for the first time and getting that, oh my God, it's very rewarding. So if you haven't participated in an outreach event, I highly recommend it. So the ones that are going on like right tonight, I'm guessing that's probably where Doug Woods is right now at Umatilla Elementary School for their STEM night. This weekend is a Valentine's and the Stars event at the planetarium. February 16th, we're having a little astronomy week at the Maitland Public Library. So on the 16th is a telescope night there. And on the 18th, we're having one as well. And I think Derek is going to be at that second one. On February 19th, Avalon Elementary School STEAM Night. February 21st is the D Ranch Astronomy Night. And if you'd like to participate in any of these, go check out the groups.io group, the outreach subgroup, and go to the calendar and RSVP on any of those. Or just join and keep an eye out and participate in the discussion about outreach events. Again, highly rewarding. I recommend them if you're at all interested in spreading our astronomy and science to the community. It's fun. And if you are a new member, I highly recommend that you read the welcome letter that you received. It explains how to get on our groups.io and it further explains the member benefits. And if you have any questions or concerns or anything like that, be sure to reach out to our board members at large, John Frank and Denise Woody. That's BML1 or BML2 at CFAS.org, or you can reach directly to me, president at CFAS.org. Let's see. And a board needs you. We're always looking for people to help out with the club. The outreach committee, as I said, I plugged that at once or twice already. Doug could use more help on the outreach committee. So if you have any interest in that, reach out, join the committee, and join in on those outreach events. And basically, all of the committee chairs could use an extra hand. So if you have any interest in events, programs, outreach, treasury, loaners, science, website, membership, observing, education, or sponsorship, that's the new one. If you have any interest in those or wanting to make a new one, please feel free to reach out to us to see how you can help. You can be on any committee and make your mark on the club and see how you can help. It's a rewarding thing. Um, Also, we are, as always, still looking for mentors for our mentorship program. I think we're getting ready to start do something with that. So if you have any interest in being a mentor, if you have a specialty in any branch of astronomy, please reach out. Any specialty is welcome. Also, I wanted to make an announcement too about the merchandise and swag for the club. If anybody has any interest in putting together or designing swag for the club, we do have a Redbubble store where you can buy like a CFAS t-shirt or something like that. So if someone has an eye for the creativity side to put together a CFAS item of some sort, merchandise, please reach out to me and see if you can help us out with like putting something together for that. I'd appreciate the help. We're looking for a little bit of assistance there. So if you want to help out in any way here or across any of these things, reach out to in either of our BMALs or myself. So,
Hey, Wes, I wanted to add something to the mentorship. We
oh
are
yeah,
also
okay.
looking for someone to take a couple Dobsonians with them, especially if you're
The Adopt a
particularly
Dob program.
yes. If you are comfortable with visual astronomy, we love to help. The idea here is you would not own, but be responsible for a Dobsonian in any maintenance. Obviously, the club would cover any cost. But then when someone needs help or needs to borrow one, if you happen to be nearby, you be the one interfacing with them and letting them use the telescope.
Awesome. Sounds good. If that's the Adopt a Dob program that if you're interested in all in like fostering a big Dob telescope, please reach out to us and you'll be able to have it at your house and loan it out to people whenever the opportunity arises. Thank you, John. And of course, again, I mentioned that the club is a 501c3 organization. Any donations made to the club are tax deductible. And we are always seeking sponsorships and corporate donations, and we are on cyber grants. So organizations like Disney and other employers are on there, and they do have a matching program of some sort. And also, don't forget the recent tax changes. I think from last year, charitable giving is now a separate thing from the general deduction. So keep that in mind when you're thinking about donations. Upcoming astronomical events. The moon is going to be near Mercury on February 18th, which might be an interesting photography opportunity. And then the next day, Mercury is at its greatest elongation. So one of your best chances of actually observing Mercury is going to be on that day. I think I glimpsed it last time, but man, it's hard to catch that one. Again, that same day, same evening, the Moon, Saturn, and Neptune are all going to be in a little small section there. So with like a wider field lens, you might be able to catch all three in one shot. On February 23rd, the Moon is going to be going over the Pleiades. I think it's going to be near the horizon, but it might still be make for a neat shot to have the Pleiades and the Moon kind of right on top of it. February 28th, the planetary parade. I wanted to bring this up because I bet some of you, if are all kind of astronomers here, amateur astronomers, some friends and family probably ask you about like, hey, what's this planetary parade? All the planets are going to be in a line, or what's going on? So I wanted to address this. So as like the planets are not going to be in like the magical circle or smiley face that you sometimes see on social media. Yes, a bunch of them are going to be up in the sky. We'll be able to see, Mercury and Venus and Saturn and Neptune are all going to be like very low on the horizon near the sun. Jupiter and Uranus are going to be up where they are, but they're not going to be anything like, especially awesome photography wise. It's not going to be what you sometimes see on social media. So, will you be able to see them with a telescope? Of course, Jupiter is going to be very high. Saturn and Neptune and Venus and Mercury are all going to be very low on the horizon and probably will look really cool if you can see that low on the horizon that day. But, just in case anybody asks, hey, what's that planetary parade? That's the media thing blowing something up. It's going to be interesting, of course, that all the planets are going to be not all, but many of them are going to be visible right there. But yeah. And then on March 3rd, there's going to be a total lunar eclipse. It's not going to be here, but if you do find yourself on the West Coast or in like the Pacific over there somewhere, maybe somebody, I saw somebody posting about asking about going to Hawaii. Maybe it'll be around this time. You might be able to see it from there. And then on March 8th, there's going to be a Venus-Saturn conjunction, sorry. They're going to be very close, and so if you have a reasonably sized telescope, they'll be very close together. And if you have a slightly wider one, Neptune will be there too. And that would actually be a really cool shot. So if you happen to be looking up then, that'll be a good time to look. All right. Finally, we have our astrophotography showcase, and we actually had a bunch of images. I mean, we did have a lot of cool, clear nights through those cold nights in late January. So we have some good ones tonight. And if you are here, I will open it up to the floor for you to talk about your image. First up, we have Jason Rowley. He submitted a few. Jason, I think you are here. Yeah, I saw you in the list.
Yep, I'm here.
All righty. Here's your tadpole.
Yeah, so I have a new telescope, an ASCAR 140 APO that I'm going to be sending to Astropeak out in Utah. So I've been getting it all sorted out, and these are some of the images I've taken with it. I'm also using the ASCAR E1 and E2 3 nanometer filters. They're really good. I have no halos or anything like that. So here's my my tadpole.
Very nice. And you said this is from that place in Utah? This is a dark sky?
No, their first building's still under construction.
Oh, okay.
This
Okay.
is
So
from my
this one's from your
backyard. So yeah, I'm just getting the telescope ready to ship out there.
awesome. Well, I can't wait to see what you can get from those dark skies.
Yeah,
Our,
me
our
too.
our members with Starfront scopes, those are good looking images. And here's your spaghetti.
Yeah, this is a 6 panel mosaic over 2 nights. Definitely needs a lot more data. But hopefully I'll get a lot of that in Utah.
Nice. This thing's huge. 6 panels. That's nicely done. And here's your Soul Nebula. I put them together so you get, I think you said was one was HOO and one was SHO.
Yeah, one was HO, one was SHO. I think the one on the right side is HO.
Mm-hmm. Nice. Kind of shows the difference between what the third filter can really add to it.
Yep.
And your jellyfish.
Yeah, this is another one that's just HO versus SHO. I kind of embellish the colors quite a bit. But
It's an artistic touch.
yeah, I like the detail that you can bring out doing that.
Yeah. Nicely done. Thank you. Next, we have John Pinto. You didn't officially send these to me, John, but I saw you post them, and they're nice little images from your S30. So if you're here, I want to talk about them.
Well, that's kind of weird, Wes. I did send them to president at CFAS.org, so we have to look into that.
Oh, did you send them to me? Oh, okay, I
Yeah.
didn't spot them. I just I pulled them off of
That's
the.
okay. No, that's perfectly fine. That's why I put them out there. So
Nice.
in case so I remember last month you had said you wanted some images of Orion Nebula. So when I got my S30 Pro just the other day, I said, hey, let me fulfill Wes's wish.
Yeah, that's what we start with, right? It's a rite of passage. Very, very nice. And that's 30 minutes on it. That's awesome.
And again, that's from my light polluted driveway with street lights everywhere. It's just I'm just amazed at what these little scopes can do. Oh, and this is not in EQ mode. This was just Alt as on its tiny little tripod.
Oh, yeah. That's amazing. That's the way they're going. They're going to get better and better. 10 years from now, it's going to be amazing.
Oh, hopefully there's an S70 by then.
That'd be cool. Yeah, with EQ mode built right into it. Yeah.
This was the actual first image I took with the new Pro. And for people who have these sea stars, everybody's complaining it never finds the sun, it never finds the moon. I took it out of the box. This is actually in my living room, just shooting out my back window. And it just found it.
This is through a window.
Yeah, this is through a window. This is, and I was expecting not for it to not have to not find it, and I have to like move the scope around. Nope.
Sure.
went right to it. So that was just an out of the box experience.
That's honestly very impressive. The little sunspots are like they're shaped very nicely for going through another layer of glass, you know.
Yeah,
Like
yeah,
you're not
yeah.
supposed to do that, and yet look at them. That's pretty good. Very nice. Thank you, John.
No problem.
All right. James Leiter, Jim, I think he said he wasn't going to be here tonight, but he did want to send out his M81 that he took. He did this out at Geneva. This is 25-minute exposures, so about 100 minutes, I suppose, and he processed this with serial. That is a nice little M81, so good job, Jim. Next up was Frank Kane, our former president. He wanted to share his dark shark. This is a very nice zoom in on the head of the dark shark. I think he took this from his scope out at Starfront. And if you ever tried to image this area, it's dark and difficult. So props to Frank for pulling this out. This is in the constellation Cepheus, and there's a whole bunch of little dark, dusty blobs out there, like the shark and the rotten fish, and there's that other little one that's like down below this one. So it's a cool area to image if you're at a dark site. So I do recommend it. So thank you, Frank, for submitting this one. John Sasson, I know you're here. You submitted this thing. Impressive. I like it.
Yeah, so this is the Crab Nebula that I did with my Celestron 9 1/4 HAD HD and the Uranus camera from Player One. It's a 585 sensor. So it's really zoomed in. It was a real pain because the guiding, especially in January when we had those high wind nights, it seemed
Oh
to
yeah.
last forever. So a lot of subs that had to be thrown out, unfortunately. Uh, that thing that big at F10, even the looking at it wrong will cause it to have issues guiding.
Yeah.
But
Don't.
I still manage about 40 some hours total. Um, so I just really, really like zooming in and looking at the details. So I think this was it was worth it, in my opinion.
Absolutely. And this was LRGB, right? No narrowband on this.
Yeah, yeah, LRGB. Maybe in the future I'll
Awesome.
take some oxygen to add to it, right?
Awesome. The detail there is amazing. Good job, John. Very nice. Next up, me. I threw in a couple this time. Uh, this was an image I took out at Geneva over the course of probably 4 or 5 different nights in the fall. This is the Satyr region, if you don't recognize it. So we have the Crescent Nebula there on the right, and I think it's the Butterfly Nebula there just to the bottom left of Satyr. There's just a whole gob of stuff going on in this area, and I took this in narrowband. I don't remember how many hours this was. I think it was around 20, but yeah, this is a busy area to process. It's pretty cool. And then this is the Cygnus Wall, the Mexico area of the North America area, if you will. So this is the nebulosity that goes along the edge of the nebula as it's starting to blow away from the star cluster. So I was pretty happy with this one. This was with my Edge HD, and it's probably around 30 hours or so of SHO. Next up, I think this is the Bill. You're here. I saw you on the list.
Yeah.
Hey, Bill.
Hey, yeah, I usually sketch right at the eyepiece on the CFAS observing log, but in this case, I didn't have that log with me. So I sketched it originally on just a regular piece of lined paper. It was a rough sketch, and from my notes and that rough sketch, then the next day I put it on here is what you're seeing now, and it cleaned up the notes a little bit so you can read it better. But the red spot at Geneva that night was really popped out, and it's gotten a lot smaller. It keeps getting smaller and smaller. And it was interesting that in the north is down to the right, and the only belt I saw in the north hemisphere was the equatorial belt, northern equatorial belt there. And in the southern, I saw those two thin lines there, and then of course the southern equatorial belt and that polar hood. So It just goes to show you Jupiter every year it looks a little different, a little different.
That's awesome.
Good to see
Yeah,
the red spot is red again. For a while, a few years back, it was a goofy salmon color. That was kind of strange.
weird. I wonder if it was an atmosphere thing. Um, if any of you have not been to Geneva, if you ever do go, be sure to stop by where and hope that Bill is there with his stellar view telescope here. One of the best views of Jupiter and Mars I've ever seen are through that scope. So if you are there, be sure to stop by and say hi to Bill and ask him if you can take a look.
Oh yeah, yeah, everybody's always welcome. The seeing was so-so. It when it steadies out, it was all right. And your brain and your eye act as a great integrator to average things out and
Yeah,
get
it's
good
the original
data on
stacking
that.
algorithm, right?
That's exactly right. And on a really good night, I took Derek's advice. I bought a different power mate, a 4X power mate. And there have been nights where I've had it up to, I think, 440 power or whatever, and it was still holding
And it
well.
held.
So yeah,
Wow.
we'll get a good night Friday. We'll see how it goes.
Nice. And then you also threw this one in here.
Yeah, this was an iPhone smash. You can see all the detail in the white block below, but that was last week on a Monday, Wednesday, and a Friday of that big sunspot group. And it just shows how it changes. And it made the headlines on specialweather.com with the changing sunspots. And it throws out some flares as well as a lot of times the CME coronal mass ejection will come out of that and gave us some good auroras. So you can kind of visually see it from day to day, see it change and literally see it coming.
Yeah. I've heard that it's so noticeable that even with just like eclipse glasses or something, you might be able to spot this thing.
Right,
It's been
right.
impressive.
Yeah.
Yeah.
Or even a sea star through a plate glass window.
Right. Yeah. So very, very cool. Thanks. That's an impressive phone smash shot. Well, maybe we'll have to bring back the phone smash competition again this year. Thanks, Bill, for
Yeah.
contributing that. Thank you.
Yeah, unfortunately, that particular sunspot group has rotated behind the sun, so we'll have to wait for it to come
Oh,
back.
bummer.
What, Bill, what
Next
about in
month.
about 2 weeks it comes
Yeah, a
back?
couple weeks probably. Yeah.
Yeah. Yeah. It's a 26-day rotation.
And well, that'll do it, everybody. Thank you so much for everybody who contributed a photo, for stopping in tonight and hanging out. And again, special thanks to Dr. Neil Farber for his awesome talk on astrobiology. I really appreciate it. Don't forget, our in-person meeting is in March, on March 7th, I'm pretty sure. But again, check groups.io to make sure and you see any announcements about anything. So clear skies, everyone. Thanks for coming, and I will see you next time. Bye.